My name is Kevin Yu. So my role in the in the involvement of Robotics Club is I'm an assistant hardware developer or a builder, aka. I'm also assistant programmer.
My name is Brett Morris, and I am mostly going to be programming with the Robotics Club, and I might need to help out the building. The challenge for me is going to be actually taking that idea and putting it into programming, because as I am new with this program, it's going to take a lot of experimentation and trial and error to really figure it out and get somewhere going with this programming. I haven't had much experience, but I've been testing it out, and I think I might have an idea of where to start.
Right, my name's Hayden, and I help design the hardware of the robot, and I'll assist with programming only if needed.
What's one of the challenges you might face when building this robot?
So far, challenges that we faced have to do with the limited amount of motors that we have. A lot of the ideas that we've come up with have to do with 3, usually 4 motors, which we only have 3 accessible. So that's one of the challenges we've developed. And also, testing the center of the peg is the hardest thing to recognize that we've come across so far. So we're still trying to figure out a way to come past that.
Should be like that. So then we have something sensing weight, and just above it we can have something that tests the center of the peg to see if it's hollowed or not. So this can be connected to a motor, say somewhere like over here. So this, as this lowers down, you can have a platform over here. So as this goes down, this will theoretically move back if it's being controlled by the same motor. But then when it raises this thing back up, this can move forward, pushing the peg over into, say, a chute, like such. And then just below it, we have the grid. Oh, that's, yeah, there. So below it, we have the grid. We can have something that moves on X and Y axis. So then, as it pushes the peg over, it falls down and onto the specified area on the grid.
Okay,
Yeah, so like if the grid was
here,
here, you could have something built around it, and then you'd set it in over top, and it moves either like on X and Y axis. And then if it was in the section, and we had the idea of a pressure plate where it can test the weight of the peg, then we can have something push it off of that like area where it detects what peg it is, and it just falls through onto the grid. So it would be relatively low to the ground. Not low enough that it would be like it would knock over pegs when it was moving, but just a bit over, so that it could. So we came up with the idea of the whole conveyor belt thing, right? So I drew a picture of it, and I had an idea of either we use an infrared or something to sense the center of the peg to see if it's hollowed or not, or we have this to drop down on top of it and like hit it.
Yeah.
So if we do that, we would need a motor to run the conveyor belt, bring this down from the top, and then our idea to get it off of here was either a chute, like going down and then over, because we could have the grid like laid underneath of it.
Well.
But we need 4 motors in order to do that, because we need one to move it out lengthwise, depth, lower the this, and also move the conveyor belt. We need 4 motors to do that. Conveyor belt onto the grid without having to use so many motors and
Well, you can make it run to an end, and it'll automatically, you have to make it square, and it'll shoot down, it'll land down. Oh, but wait.
Well, it would need to adjust in 2 directions to hit the grid, because there's 2 rows of 3.
You're right.
So we need to adjust it in 2 different directions. I don't know. I've never used like motors and gears and stuff, so I don't know if we could do that. Like making multi-purpose, like one motor rotates it out, over, back, and down.
Is here, I have everything in a loop so that this condition is always running and it's always checking to see if it's actually happening. So here I have the color sensor and it's comparing the colors. So if it doesn't sense a color, it will just wait and it'll do nothing. And if it senses green, it'll rotate 20 degrees at a speed of 25. And if it senses red, it will rotate 200 degrees at a speed of 25. So then if it senses green, it'll go to the green column, and then if it senses red, it will go all the way around to the red column.